the sun dominates our lives. During the day, plants and animals flourish thanks to its warmth and light. At night, the sun still finds a way to aid and comfort life on Earth by reflecting off the moon. On this planet, going very long without seeing the sun is impossible because it is the largest and brightest body in the solar system. Yet, the sun isn't that enormous for a star. In fact, it's about average in size. There are countless larger stars in existence. So what is the largest star found so far in the universe? And where does it live? Let's find out. Defining what a star is essential for understanding how the biggest star ever discovered works. Stars are massive astronomical objects composed of burning gas that emit radiation from internal reactions. While hydrogen and helium are the most common elements found in stars, others may also be present. The universe is home to an incredible number of stars, so much so that Carl Sagan once remarked that there are more stars than grains of sand on all the beaches on Earth. From our vantage point on Earth, we only see tiny specks of light, but stars are actually so much larger. Stars undergo changes throughout their lifetimes, with their life cycle playing a significant role in determining their size, just like living beings. The life cycle of a star can be complex, so let's review it briefly. Each star starts as a stellar nebula, a cloud of gas and dust that condenses via gravity for millions of years, eventually forming protostars and main sequence stars. The lifespan of protostars depends on their mass, with smaller ones becoming brown dwarfs that cannot initiate hydrogen fusion. Main sequence stars, on the other hand, are large enough to start nuclear fusion. When hydrogen is depleted, smaller stars, such as our Sun, will eventually turn into red giants, expanding and expanding for hundreds of millions of years. This growth will result in Mercury, Venus, and Earth being engulfed by our Sun. Main sequence stars that are more massive will expand into gigantic red giants that eventually collapse, creating a supernova explosion and potentially forming black holes or neutron stars. Massive main sequence stars use up hydrogen much faster than smaller ones. The cycle ultimately ends with white dwarfs that turn into black dwarfs and cease to emit heat. As you can see, a star's life cycle is intricate, resulting in various sizes and stages. So how big is the Sun in our solar system? The Sun has a diameter of 865,370 miles. While that seems huge to us on Earth, this fact classifies the Sun as a dwarf star in the main sequence. Around 5 billion years from now, it will run out of hydrogen, at which point it will eventually turn into a red giant. The diameter of Earth is 7,917 miles. Therefore, the Sun is roughly 109 times wider than the Earth. Obviously, this size will grow exponentially when the Sun evolves into a red giant. That covers the biggest star in our solar system, and the only one. So what is the largest star that is currently known to exist in the cosmos? Stephenson 218, an M6 spectral type red hypergiant, has a diameter of 1.86 billion miles and a radius that is 2,150 times that of our Sun. It is the biggest star currently known in the universe. It has a surface temperature of 3,200 degrees Kelvin, and it emits 440,000 times the light of the Sun. Its size is nearly 10 billion times the Sun's volume. At the speed of light, it would take almost 9 hours to travel around its surface, compared to just 14.5 seconds around our Sun. Its diameter is nearly the same as Saturn's orbit. The fastest jet on Earth would need more than 500 years to complete a single journey around Stephenson 218. The Earth is a speck of dust compared to this massive star. Likewise, the Sun is shockingly tiny. It takes 19,000 years for the light of Stephenson 218 to reach Earth from its home in the constellation Scutum, in the Scutum Centaurus arm of the Milky Way. It is important to understand that stars lack a defined boundary, or surface, like a rocky planet such as Earth. Instead, they consist of superheated gas that gradually thins out into space. While we have never directly measured a star, we have estimates based on various variables, such as distance and surrounding structures. However, because stars are made of hot plasma, there is no linear relationship between weight and size. Although Stephenson 218 is currently the largest of known stars, it is not the heaviest. Westerhouse 49-2, with a mass of nearly 250 solar masses and a brightness of almost 4 million times that of our Sun, currently holds that title. The universe is home to an incredible array of stars, each with unique sizes, characteristics, and life cycles. While our Sun dominates our daily lives, there are countless larger stars in existence, including Stephenson 218 and Westerhouse 49-2, the largest and heaviest known stars, respectively. Understanding the complexities of a star's life cycle is crucial to comprehend their size, and while we may never directly measure a star's size, we can estimate it based on various factors. So while the Sun may seem enormous to us, it is really quite small compared to the vastness of the cosmos. Thanks for watching.